Hello, guys. So, today's class is basically a new chapter, a new topic. Uh, but because what I think that the last chapter, though there are more numericals we have to solve, but what was the basic things you already have understood. So, we are moving to our next topic, and again, we will come back once our whole dynamics is done. We will come back to miscellaneous problems and we will solve those problems. So, till now, what we have learned? Till now, we have learned about the motions in one dimensions, right? That means where you only have to talk about x, one parameter of distance. So how much x is covered in which time, what is the rate of change of x, what is the velocity, that means, and what is the rate of change of velocity, that is acceleration. So all those things we have learned. Also we have learned three equations of motions, that is basically our uh, three equations of motion, that is uh, v equal to u plus at, v square equal to u square plus 2as, our s equal to displacement ut plus half at square. These are basically three equations of motions, right? Motions. Now you have seen here only we are talking about one dimension, but in real life the motion can happen in three dimension or two dimension. So we are moving motions in two dimension. What is dimension? First of all, one dimension means only one parameter is needed to locate any object. So let's say this is my origin O and this is only one line. The object can lie into one line only, let's say. Or you can think like that ki one big wire is there, and one ant is walking through it. So the distance of the ant can be said that the ant is, let's say, 5 centimeter from extreme left corner. So it's like 5 centimeter. If I say, you can easily find out the ant, you can easily track the ant. So that's why only one parameter x is needed and it is called 1D. But whenever the situation will be such that one ant is moving in a page like this, and right now it has come to this point. So how to locate this? What we do, we usually in this kind of situation we take help of two parameters. One is x, one is y, and we say that to find the ant we have to go, let's say, 5 centimeter along y and then 7 centimeter along x. So I will say the position of the ant is x comma y, or in this case your 7 comma 5. So these things we do. Usually I have done one like conventional mistake. So why I'm saying conventional, because usually people take these as x and these as y, and in coordinate system we write horizontal component at first and then we write our vertical component. Okay, but the main thing is there, we are using two parameters to locate the position, right? When we will talk about our let's say motion in 2D, we need three parameters, that is x, y and t. Time, obviously we need time. Like in one dimensional motion we were using x and t, these two parameters, mainly the basic parameters, and with help of these two we have got this velocity, acceleration, average velocity, these terms. That means displacement and time. Here we need two displacements parameters and one time parameter. Fine. So before we go further in motion in 2D, so somewhere you can also learn that motion in 2D is written as motion in a plane. Why a plane? Because when you have a two-dimensional space, one surface cross section, like one surface cross section will be called as plane. Okay, so this is one plane. So the ant can move only in this plane. It cannot go out of your screen, right? So that's why it's two-dimensional. In three-dimensional, it can come out of your screen and it can fly into your room. So that will be three-dimensional. Okay. Before we move into two-dimensional motion, we have to know about vectors. So before I start, let me tell you something about scalar also. So generally physical quantities, so physical quantities are divided into two parts. One is called scalar, one is called vector. Scalar quantities are those quantities which are having no direction. Vector quantities are those quantities which are having definite directions. Now let me clarify it. See, let's say I am telling you that there is a ball. Now let me draw a nice ball. It looks bad. Okay, and let me okay, so this is your ball. Now if I tell you push the ball with 5 Newton force, now you will be confused. You will think, from which way I will give the force? If I give the force in this way, the ball will go this way, right? If I give the force this way, the ball will go this way. If I give the force this way, ball will go this way. So I must tell you some direction before I say you apply this much of force. Let me tell you the position of the ball is O. This is A, this is B. So if I tell you give 5 Newton force to this ball along OB direction, then it is clear that you have to give your force this way so that your ball can come from O to B. Okay, so these things like force must have some direction. So this kind of quantities, okay, like force and your what you say velocity, displacement should have direction. Why displacement should have direction? See, in this case the ball is going from O to B. See, if let's say you are having a a situation like this, you have a small ball here and you have a circle like this here. Now the small ball is here and this is your position A, this one, this is your position B. See, in this case your OB, OA and OB both are same, like the length wise. AB, OA and OB are same. So if I just say the ball has covered, say this is 5, the ball has covered 5 centimeter distance. So what you will think, the ball can come here, the ball can come here, because these all are 5, because it's radius all over the places it's same. So I have to tell you some definite direction, that the ball has covered 5 centimeter along OA direction. That means I have to tell you that this is the direction the ball has covered distance. It was here and now it has covered a distance 5 and it has come to a point. So this is how I have to tell you. So the quantities which are like, which must have some direction, they are called vector quantities. So vector quantities are those quantities which are having some direction. Now which are vector quantities? Some examples like whatever I have said: displacement, then you have your velocity. But you must remember, I told before only, that velocity is having this like direction, displacement is having a direction, but actual distance and speed, these two terms are not having direction, because actual distance means it, the ant can go like this, and like actual distance doesn't have any certain direction. Like it, in this case it is going this way, in this position it is going this way, in this position it is going this way. So there is no certain direction. So actual distance is not having direction. Speed is equal to what? Speed is equal to actual distance by time. As actual distance is not having any direction, so speed is also not having any direction. Okay, so that's why those are scalar quantity. I'm coming to that now. So what are this? Like displacement, velocity, acceleration, because acceleration is velocity, change of velocity by time. So velocity is vector, so acceleration is also vector. Acceleration, force, and there are certain such things. Okay, now what are scalar quantities? Scalar quantity means the quantity those are not having any direction. Scalar quantities, scalars, like volume, you don't need any direction for volume, right? Volume, mass, you say this is 5 kg, you don't say this is 5 kg in this direction, right? So it doesn't depend on direction only. Acha. Later on you will know that pressure, though it is dependent on force, but due to some reason pressure is also not having any direction. Then you have your time. Time is also a scalar quantity. Then you have your uh, so these are some quantities. Okay, like acha. One more thing, vector, one shocking thing, that area is also a vector quantity, and we will come back to this. But like what is now, you can say then like what is so special about it? If something is having direction and something is not, what is special about it? Special thing is that, like scalar quantity, you can say that volume is, or better I say the mass of some object. Say I have two objects, the mass of one object is 5 kg, mass of another object is 6 kg. So their total mass, I can always say that MT total mass is 5 plus 6, 11 kg. But in case of vector, let's say I am giving some force 4 Newton to something, and also I am giving force 5 Newton over that thing only. Like one single thing is there and I am giving force. But I cannot say that my total force is equal to F1 plus F2. I cannot say. It may be, but it depends on the situation. Why so? Let us try to understand the fact. Let's say I have this ball which was here, and then I am using 5 Newton and 6 Newton forces. Now if two forces are given in the same direction, so 5 and 6, the result will be 11 Newton. But if say I am giving two forces in different direction, 6 and 5, oh my god, 6 and 5, so the result will not be 11, because then what will happen? The total force will be 1 Newton in this side, because they will cancel each out. So you can easily understand this thing. If you just keep your mobile in a place and with one finger you are pushing it, another finger you are pushing in the opposite side, so you will see that there is a cancellation effect on it. But if you push in one side with both the fingers, you will see your total force will add up. You can experience it nicely. That means the direction of my applied forces are also important in order to calculate the resultant force. So if say I am giving force like this and this, like say this is 5 and this is 6, I can expect the resultant force will be in this way, but I cannot calculate the resultant force value so easily, like just arithmetic addition. So we have to find out how to deal with multiple vector quantities. Now, talking about vectors, there are many kind of vector quantities. You will easily find those vector quantities, the classifications in your book. There is something called collinear vector. Collinear vector means two vectors, like two forces, are working in a same line. They are called collinear vectors. Okay, like 5 and 6, what I was telling. If two vectors are working in like single line, that is two vectors are collinear, their resultant, that means the total of their effect will be just add up, like 5 and 6 will be 11. There is something which is called coplanar vectors. Coplanar vector means two vectors working in a same plane, and basically we will be doing our like analysis over this kind of vectors. Collinear vectors, like say one force is F1, one force is F2, and they are having one angle theta between them. This is called collinear vectors. Okay. Now something is there is called your what is there, your parallel vectors. Parallel vectors means two vectors are separated by their origin point, but in the direction is same, so they are parallel kind of vectors. Okay. Something is there is called null vector. Now we will come to this null vector after some time. Null vector means the magnitude is 0, though there is some direction. But before we understand this, we have to understand how a vector quantity is represented. So as we have said that force should have two components. One is its magnitude, to understand its strength, and its what you called the direction. So the magnitude and the direction. So these two things, how to implement it with each other, like how can be integrated. So we write like this: force, we give one arrow like this. This arrow means it's a vector quantity. Now this arrow you don't have to give like let's say this. You cannot give like this, or you cannot give like this. You have to give this arrow like this, always towards right. This is a conventional method of doing it. So if you write anything with the arrow, that means the quantity is a vector quantity. The vector quantity is having a magnitude, and that is shown with this modulus sign or symbol, and the direction is shown with this sign. Now what is this? This is called cap. This small thing is called cap. It's kind of cap, and that's why it's called cap. So this cap means only direction is concerned. So this is only the direction part, and this is only the magnitude part. So you can say that sir, if the direction is this one, so like how to, like what will be the value of this thing? So usually if you measure the value of this thing, that is 1. This is called unit vector. But actually this unit vectors represents only direction. So f cap represents a direction. Now I am telling you how it's representing a direction. Let's say let's come to this where is that? Oh, I have removed. Okay, let us draw it again. So we have this ball, and the ball has to come from this O position to your A position. So the ball will come from O to A. So I have given a force F. So my force F will be the value, let's say I have given 5 Newton force. So the value is 5 Newton, and the direction is OA cap. So if I write this thing, that means, now you will say where is the mod? So mod we use in case of variables, but here 5 is itself a value only. So I am writing this 5. OA cap representing the direction of the force being applied. Okay, so this is how we represent vector. Now if I am giving 1 Newton of force, what will happen? So if I am giving 1 Newton of force, so this will be your 1 into OA cap. So it will be your OA cap only, and this is called, this vector, then F will be called as a unit vector. Okay, so unit vectors are the vectors which are having the modulus equal to 1. So unit vectors, let's say x is a unit vector, so x cap, so x is a unit vector, we can write x equal to x cap because the value is 1. So if I just take the value of x now, that will be 1, and that I have put it here. So these are called unit vector. And somewhere if your x is 0, then it is called a null vector. But null vector means this x will not be 0. The value is 0 only, but x is not 0. X will be only its your what you say directional value. Okay, so null vector is also, now this is very confusing, this and this look same. Now you will tell what is this thing, sir. Here we can see the value is 1, but here we like, but you are telling the value is 0, null vector. So the thing will be clear slowly once we will deal with vector. But null vector means the value is 0, but there is direction still now. Okay, and unit vectors means the value itself is 1. Now coming to another point, we will now what we will do, we will basically start to analyze everything in terms of vectors, because velocity is also vector. So if something is moving in two-dimensional like plane, then it will have the displacement along x side also, it will have a displacement along y side also, right? So it will go like this. So there will be like two components, one is for this x shift and one is for y shift. So x shift and y shift, we will be having two components. So we will be also having two kind of velocity, one is the velocity for x axis, one is the velocity for y axis. When they will come all together, we will get a resultant total velocity. So we will try to split everything, every kind of problems in with two parameters for two-dimensional motion. Okay, now one more thing I have to tell you before I start the superposition theorem, that means addition and all those things, your acceleration, that means the gravity, is also a vector, right? Like g. And whenever you remember that whenever we were doing something like this, that something is dropping down in a ground, we were saying that the velocity will increase because the like falling is also like increase of displacement is also downward and the acceleration is also downward. So the whole equation was plus u plus gt. But if I am throwing it upward, what was happening in that case? So up, when I am going up, the displacement is increasing, but when I am going down, displacement is decreasing. So see, g and x is now different. So instead of, so now you know that g, that means the acceleration, is a vector quantity because direction is important here. So as we are now going up, the direction is changed or flipped. So what we do, instead of this we use minus signature here, and that means it's a retardation, that means the v is decreasing. But you can always like compare these two things, okay, with help of vector also, that due to vector, as we have changed the direction, so the signature is also changed. So these things are there for like today, and the day after, like tomorrow, we will start superposition theorem. That is, if you have your two vectors, let's say force, because force is like simple thing to understand with. So let's say f1 and f2 both are being applied with theta angle. How to calculate that, what will be my total resultant force and in which direction it will be? It will be in this direction or in this direction or in this direction. Okay, so this we have to find out. So next day we will be doing that thing, and then we will also do something about multiplication of vectors. One last thing I will try to tell you, that I told you already that area is a vector quantity. But you must be thinking how it can be. Area is kind of plane, the space inside a like some closed what you say structure or closed loop. Then what will be the direction of the area? Now the direction of the area is taken as normal to the plane. Normal, that means right now you are looking at your mobile screen, so the direction of the mobile surface will be perpendicular, that means just normal to the surface of that mobile, that means coming out of the screen. So this is taken as the direction of area. Why? We will come back to this when we will study relative velocity while doing the analysis of rain and your umbrella. Okay, so you just pause that thing for now. We can also like judge this thing with our solar shadow, okay, and umbrella. So we will come back to that thing later on. For now you just remember that area is a vector quantity, and the direction is taken as the normal. So normal direction is called as n cap, normal cap, that means it is perpendicular to the plane. And let's say if the area, the value of the area is a mod, the value, only the value, numerical value, so a can be written as this n cap. So this is it for today. So you have learned today about your physical quantities vector and scalar, and the parameter which we will be using for 2D motion. Fine. So see you tomorrow or the day after tomorrow. Fine.